From there, we have our articulating cusps. So our articulating cusps, basically, this is like a frame that helps show us the relationship of the patient's maxillary and mandibular jaws. So it helps keep them in shape, as in the models from the impressions that you took, so that you can just see the relation between the maxillary and mandibular jaws. Okay, so that's basically the function of articulating cusps. So yeah, they are frame holding models. So then you basically use plaster, again, the plaster that we maintained, the type 1 plaster, if I'm not mistaken, that you basically use on the frame to help keep that relationship, that occlusal relationship, in place. So having that in place, then it helps you carve out the patient's occlusion. You can carve out teeth, you can make out how the patient bites, you can diagnose the patient, even though the patient is not necessarily in the chair, by making use of the models and the articulator that you had just used early on before. And then from there we go on to our face bow. So our face bow, it's nice to know, just know about it, because normally it's the dentist that actually uses it. In private practice, you hardly use it unless you have completely edentulous patients, or even if the technician himself can't make out certain measurements. So with the face bow, basically it is a device that helps you take measurements, and it basically, more than anything, tries to show you the relationship of the maxilla relative to the TMJ, okay, and its functioning. And again, can be used for dentures mostly, and as well crown and bridge to a lesser extent. And then from there, basically, like I mentioned before, it is used to mimic the patient's TMJ function with the use of an articulator as well as an impression model. So good impressions are very important, because you're going to translate them into your articulator, and they're going to have repercussions for your face bow work. So it's just a lot. You just have to make sure that everything is accurate throughout the various steps. Okay, and then in dentistry, we also use quite a lot of waxes. So you have to know that there's 3 types of waxes that we use. So we have pattern wax, processing wax, as well as impression wax. So with pattern wax, basically it comes in this very darkish color, and then we can use it on dies. So dies are normally the positive replica of a prepared tooth that we are basically working on. And then the advantages of pattern wax is that it is quite hard, it is quite tough, we can make it into like a smooth surface, and it is quite resistant to flaking. Then another nice thing about it is that its temperature is normally higher than that of the oral cavity, so it just makes it even nicer and easier to work with. A type of pattern wax would then also be a base plate wax. So this is the wax that we basically forms the base of a denture. So that pink surface of a denture, yes, so that's base plate wax. And then base plate wax has 3 types of 3 types, if I can put it that way. That is type 1, type 2, and type 3. So type 3 is normally the hardest, and is the one that we use to make the basis for dentures. Then under processing wax, we have 3 types of waxes. That would be the boxing wax, the sticky wax, as well as the utility wax. So with the boxing wax, it's very soft and pliable, and then it can be used to create like a wax box around an impression before you actually place gypsum into the impression material. And then from there we have sticky wax. So sticky wax is quite brittle at room temperature, but the main advantage of sticky wax is that it can actually attach onto a number of surfaces, such as ceramics, such as metals, as well as gypsums. And then from there we have utility wax. Utility wax is the one that we normally use around the peripheries when we're taking impressions. So you can actually mold that one without actually applying heat onto it, because it's very soft and pliable. So those are the 3 types of waxes that form under processing waxes. Then the last subtype under dental waxes is then impression waxes. So impression waxes are basically used for bite registrations, just like we had mentioned earlier on. And then there are various other types of waxes that we use in dentistry, but not that commonly, being the likes of study wax. So study wax is basically wax that we use to create teeth as well as anatomy. And then we have undercut wax. So this is the wax that we put in areas of undercuts before we actually take an impression, so that it doesn't hurt the patient and it doesn't affect our impression when we take it to the lab. Okay, and then from there, we're on slide number 24. So we're talking about custom trays. So there are 4 types of custom trays that are discussed in your slides. So there's the acrylic tray resin self-curing. So that is the most common type of tray. So that's basically where the lab takes powder and a liquid, being the powder being a polymer, and then the liquid being the monomer. Then you mix them together, you mix, and then they become a liquid, and then it undergoes polymerization. So it's all these short chains that become one long chain to basically make custom trays. Custom trays, ladies and gentlemen, are very important in dentistry, especially when you're fabricating things like dentures and stuff, because they allow for an even better adaptation of the patient's oral cavity, a more accurate adaptation of the patient's oral cavity. And sometimes these stock trays that I've been showing you all day really just don't fit into the patient's oral cavity. Either they hurt them, or they're too far back, or they're too short, so that you're not getting all the information that you need to record on your models. So that's where basically custom trays come into, because sometimes just using these alone, the stock trays, they don't give an accurate portrayal of what is happening in the oral cavity. So when the final product comes, it's too short, it's falling out, there's just all sorts of problems that could have been avoided if you used custom trays. So with the acrylic resin self-curing one, like I said, it forms polymerization chains. So basically the powder and the liquid, they undergo that liquid stage, and then they harden, then they become soft again. You're going to see as they polymerize, they become like sticky. You might see that in the lab. And then eventually, once they get to their hardened stage, they release a lot of heat. So you can literally just even put the palm of your hand on top of that material, and you'll feel the heat dissipating from it. So because it's not dimensionally stable, it takes about 24 hours to set. So when you're making your custom tray on top of your model, you'll have to leave it for 24 hours, and then you'll have to check it the next day before you actually start trimming it, before you call the patient back. And then nextly, we have our acrylic tray resin light curing custom tray. So that's basically this tray is going to undergo the same process with the liquid, like the monomer and the polymer. The only difference is this one requires you to actually operate it. So you need to actually get a light source to switch on the light source to actually initiate the polymerization and the hardening of the material. And then from there, we have vacuum formed custom trays. So this is when you actually then you need a vacuum machine. So this is additional time, additional resources. Né? So you basically need this vacuum machine. Né? Then from this vacuum machine, it's gonna have like a sheet. So you're gonna put your model in, and once you close the machine, this sheet, it is gonna sink onto your model, and then it's gonna like vacuum like. Then in that suction action, it's going to conform to the impression of your primary impression, so that it then fabricates a custom tray on your behalf. And then from there, the last step would be the thermoplastic tray material. So this is basically when you take these beads, né? Like we're saying, thermoplastic, so they require heat. So in requiring heat, you basically have to melt them, and then from there they become like nice and clear and pliable, so that you can actually then form your tray using heat. And then once that cools, then it then hardens into your tray, which then you'll have to trim accordingly to make a custom tray. So it's basically different materials, the first one being the easiest and the longest, being also the most common one, and the acrylic self-curing tray. But then the others then require additional resources, being the vacuum machine, the light source, as well as then a heat source for all of them to work efficiently. Okay, and then we have the constructing of a custom tray. So we've previously highlighted all the types of materials you can use to fabricate this custom tray. And then from there, with the model, obviously, then you have to customize it, make sure there's no undercuts, make sure there are stops if necessary, make sure that you guys place rests on those customized trays. But that's mainly lab work, so I don't want to get into detail, but those are the things that you have to make sure are covered once you are trimming your model and then fabricating your tray thereafter. And then from there we have vacuum formed trays. So vacuum formed trays, basically using a vacuum. These vacuums come with acrylic resin sheets. So when you press the machine to switch it on, it starts heating, and as the sheet heats, it then sits onto your model that you make from your impressions. So after it seats, And then you're just going to switch the machine off, and then you're going to wait for it to cool for about 1 or 2 minutes before it actually becomes firm and conforms to the shape of your model. Thereafter, obviously, you're going to remove it from your model, and then you're going to start trimming using the appropriate scissors up until it gives you what you want. But these vacuum foam trays, the tray itself, it's a bit expensive, but it has quite a lot of uses in terms of like fabricating trays, fabricating appliances, fabricating bleaching trays. It just has quite a lot of functions, so in that regard it's very useful. But I think that, like I said, it must adapt to pressure. It has a heating element as well as a cast, but I think those are some of the things you guys will see in your lab. And then from there, we're going to cover temporary restorations. There's really not much to say on them. There's 5 types. So there's your preformed aluminum or acrylic crowns. So they're just like little metal shapes. They take the shapes of normally your premolars as well as your molars. And then for the anterior ones, they normally are ceramic or porcelain or resin shaped prefabricated crowns. So obviously with the anterior teeth, you're not going to have metal temporary restorations. So then from there we have the acrylic ones or the composite matrices. So these are all 3 are self-cured. So it's polymethyl methacrylate. Polymethyl methacrylate acts just similar to your polymer and your monomer in terms of the polymerization process. And then there's the self-cure methacrylate as well as the self-cure composite material that you place, and then you then just form so that it adapts to your tooth properly. So the ones that are preformed, they're very nice. You just have to make sure that you choose the appropriate size, and then if you get like the one that's closest to the tooth but it still doesn't fit properly, you can just make use of scissors just to crimp as well, to crimp the tooth, the preformed restoration to fit onto the tooth and adapt to the gingival margins properly as you guys would like it. So that is basically it. Then the dental check is okay. What vacuum foam trays are mostly used for, like I said, custom trays, bleaching trays, night guards, mouth guards, matrices, as well as provisional restoration. So from that one vacuum tray, you can actually fabricate quite a lot of things using it, heat, as well as the resin acrylic sheet. I hope you guys enjoyed this lecture. If you have any questions, please email me. A lot of the things, do not be disheartened, you will be seeing in the lab, so you can correlate what you saw in terms of the material and the products that you guys saw in the lab with my lecture, put them together, study hard. This is a very, very important part of the work, an important scope of your work. So I hope you enjoy, and I'll see you guys next week with about 2 more lectures that we will be covering. So I'll see you guys next week. Ciao.